Hi, Assalamualaikum and a very good morning. So now we are in chapter 4, which is Introduction to Organic Chemistry. We are going to focus on the subtopic of 4.3, which is Isomerism, part 1 of this video. So in this video, we're going to learn into the definition of isomerism. Also, we're going to explain the constitutional isomerism, which is we have the chain isomer, positional isomer, and functional group isomer. So, without any further ado, let us start. So, isomers are basically compound with the same molecular formula, but different arrangement of atom. Isomer can be divided into two. First, we have the constitutional or structural isomer. Second, we have the stereoisomer. Structural isomer is the compound with the same molecular formula, but different structural formula. Okay, so in this video, we're going to look into number 1 first. Alright, so number 2, we're going to deal with that in the next video. Okay, so let's look into number 1 first. So the constitutional or the structural isomerism, the one on the left, going to be divided into two, divided into three, which is chain isomerism, positional isomerism, and functional group isomerism. For chain isomerism, it basically differs in the structure of the carbon chain. Okay, and for positional isomerism, it is differ in the position of the functional group. So, functional group, which is for example OH, will change its position. For example, if we have CH3, CH2, CH2, OH. So at first, maybe the OH is attached at carbon number 1. However, its isomer can be attaching at the middle carbon, which is carbon number 2. Okay, so this is isomer 1 and this is isomer 2, where you can see that the position of functional group from carbon number 1 become carbon number 2. Okay, OH attached at carbon number 2. Okay, but for number 1, it only changes in the carbon change, where we're going to look into the example at the part. And for the third isomer, it's going to be a functional group isomerism, where they have the same molecular formula, but now different functional group. Okay, for number 2, the functional group is still the same, but for number 3, it's totally a new functional group. All right, so let's look into each and every cases of this in the later slide. So we're going to start with the chain isomerism first, or known as the skeletal isomerism. So chain isomer have the same functional group and belong to the same homologous series. However, for the chain isomer, it only differ in the structure of their carbon chain. So we only focus on the carbon chain. Alright, for example, we have C5H11OH. So we can draw C5H11OH, which is pentanol. Okay, because OH refers to alcohol and pentane refer to 5 carbon. So we can draw our first isomer as like this, which is CH3, CH2, 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 OH. So this is 5 linear carbon. Okay, in a straight line, we have our 5 carbon. 1, 2, 3, 4, 5. So usually we will start naming our carbon from the nearest functional group. Okay, now we're going to make another chain isomer. So in order to make another chain isomer, we will usually make a branch. Okay, kita akan membuat rangkaian pada carbon yang lain. So what we're going to do is we're going to reduce the length of the carbon from 5 carbon to become 4 carbon. Okay, so what we're going to have is 1, 2, 3, 4. 4 linear carbon. And one of the extra carbon here will then be attached into number 3. Okay, and this produce number 2, second isomer. Alright, or you can, if you don't want to put it at number 3, you can bring this thing at number 2. Alright, so what you're going to produce is to be something like this, where it also have 4 carbon, but now it attached at carbon number 2, number 1, number 2. Here at carbon number 3. So this is another different isomer. And for for isomer 1, isomer 2, and isomer 3, they all have the same molecular formula, which is C5H11OH. So 1, 2, 3, 4, 5, C5, H gonna be 3 plus 2 plus 2, gonna be 7 plus 2, 9 plus 2, 11, OH. So it's gonna be the same as the example. Same goes to here. 1, 2, 3, 4, 5. So going to be C5H4, 8, 2, 4, 5, 8, 11, OH. So it's still the same. Same goes to here, which is C5H11OH. Okay. And for this part, we can also bring, we can further reduce the carbon chain, become 3 carbon. 1, 2, and 3. Okay, so now we have 2 attachment at carbon number 1. Okay, and the molecular formula is still the same, which is C5H11OH. 1, 2, 3, 4, 5. Hydrogen got 3 plus 2 plus 3, which is 8 plus 3, 11, OH. Alright, so it is still maintained. And this is has a 3 length carbon. Okay, so tadi ada satu rangkaian tetapi tempat berbeza. Isomer yang ketiga, satu rangkaian tetapi dekat carbon yang lain pula. Manakala for the fourth isomer, we have 2 branch at the same carbon. Okay, and this is where we can differ the structure of carbon chain in order to get different isomers. Okay, alright, and if you were to look at here, you will have the tendency to bring this thing, for example, this carbon, into the first carbon here, right? Okay, you might want to do that, but what basically happened here is you're gonna get CH2, 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 OH, and then you attach this carbon here to the first carbon, which is like this. Okay, so what gonna happen here is that this is not gonna be the isomer. Okay, this is because the OH here is attached at the second carbon. Okay, so at all of these cases, OH is attached at first carbon, OH is attached at first carbon, OH is attached at first carbon, OH is attached at first carbon. But for this case, usually we will start the naming from here because it is the longest carbon chain. So as what you can see here, it become 2 OH. So here the position of OH has changed. Okay, so in order to further understand this, we're going to look into the positional isomer. Okay, but for chain isomer, this is not accepted. Alright, so let's move on first, and we're going to look at it again in the positional isomer. So now we're going to do example number 2, which is C8H10. So for C8H10, we can draw the structure to be something like this. So 1, 2, 3, 4, 5, 6. So we're going to have 6 carbon and hydrogen here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So C8, H10. 1, 2, 3, 4 plus 3, 7 plus another 3, 10. Okay, so this is going to be our first isomer, or we can call it as 1, 2 di, because got 2 methyl benzene. Okay, so this is first one, which is 1, 2 dimethylbenzene. And we can make another isomer by changing the position of CH3 into here. Okay, and for this case, we're going to name it as 1, 2, 3. So we're going to call it as 1, 3 di, because got 2 methyl group benzene. Okay, so 1, 3 dimethylbenzene. And if you're going to make another isomer, we can bring this into this part. Okay, so it's going to be 1, 2, 3, 4. Okay, which is 1, 4 dimethylbenzene. All right, and you might have the tendency to bring this carbon into here. Okay, so if you were to bring that, you will get CH3 and CH3. So it basically the same as this one, because it's gonna be 1, 2, and 3, because it has the lowest. You need to do the numbering which has the lowest combination. Okay, so you will learn more about this in the next chapter basically, and also do the naming in the next chapter. But basically, as what you can see here, this structure and this structure are basically the same. It's just being flipped over. Okay, and that is why we only draw it one time only. Okay, so if you were to bring this to here, it's basically the same as this one. It's just the flip version of it. So it's basically the same. So we only got need to draw one each time, which is 1, 2 dimethylbenzene, 1, 3 dimethylbenzene, and 1, 4 dimethylbenzene only. All right. Now we move on to the positional isomerism. So positional isomerism have the same carbon skeleton. So carbon skeleton tadi masih di-maintainkan and have the same homologous series, but differ in the position of the functional group. Okay, so functional group tadi akan berubah dia punya posisi, tetapi carbon chain dia masih maintain. Okay, so let's look into the example of C3H7Cl. So if we were to draw C3H7Cl, we can draw it as CH3, CH2, CH2, Cl. So Cl is being attached at the first carbon. Now, if we were to change the position of Cl, so sorry, this one is known as 1-chloropropane because it attached at carbon number 1. Now we can bring the chlorine into the second carbon. Okay, and now it becomes 2-chloropropane. So in both of these cases, the molecular formula is still the same, which is still C3, 1, 2, 3, H3 plus 2 plus 2 going to be 7, Cl. Same goes to here, 1, 2, 3, C7, sorry, C3, H7, Cl. But now the position are changing because it attached at carbon number 2. Alright. Now we're going to do C4H8. So C4H8 basically refers to alkene. Specifically, carbon number 4 refers to butene. Okay, so we can draw butene to be CH2, CH, CH2, CH3, or we can make the double bond in the middle. So this is known as 1-butene, and this one it is called as 2-butene. Alright, so you might also have the tendency to bring it to here, but it is basically the same CH. Okay, so it is basically the same as what you have drawn here. So it is sufficient for you to draw one butane and two butane only. Because if you were to bring this double bond to here, it's gonna have the same name, which is one butane. Okay, it's just being flipped over. All right. For positional isomerism, example number 2, we have C3HO. Okay, so the first species that you can draw is C3, CH3, CH2, CH2OH, which is known as 1, 2, and 3. So this is known as 1 propanol or propan 1 all. Or you can bring the OH into number 2 here. So it's gonna be propan 2 all. So the conclusion here, both have the same carbon skeleton. Carbon skeleton dia masih maintain, masih dalam bentuk straight. We doesn't change the bonding, become rangkaian. Kita ada buat rangkaian pun. But they only differ in the position of the OH group. From number 1, it become number 2. Now we're going to go to the third isomerism, which is the functional group isomerism. So functional group isomerism have the same molecular formula but different functional group. Therefore, they belong to different homologous series. Okay, and because they produces different functional group, they have different chemical and physical properties. For example, when the formula, which is CnH2n plus 2, O, and n is greater than 1, we can make two clusters of compound, which is alcohol and ether. And this applies to all the other species. Now, let us look into the example in order to understand this situation better. Okay, so example number 1, we have the molecular of C2H6O. So, if you were to look at here, it's going to be this thing, which is C2, 2 multiplied by 2 plus 2, O. So n is equal to 2, right? So it's basically you can draw an alcohol and you can draw an ether from the structure here. Okay, so you can draw alcohol and ether where n here refer to 2. Okay, so first you can draw an alcohol which have a formula of CH3, CH2, OH. So the molecular formula is still the same. The number of carbon the same, the number of hydrogen is the same, number of oxygen, which is 1 to 1, is still the same. So you can draw the first isomer, which is ethanol, okay, because it has 2 carbon, ethanol. Or you can draw another class of compound, which is ether, known as dimethyl ether. So methyl group, di because it got two the same, and this functional group is known as ether. So you will learn about the naming in the next chapter. Now going to example number 2, where we have a molecular formula of C3H6O. So C3H6O, it applies to here, where n is equal to 3. So C3H 2 times 3 becomes 6, and O here. So you can draw an aldehyde and ketone. So for aldehyde, you're going to have a formula of CH3, CH2, COH. So it's going to be like this. So this is called as propanal. Okay, because al here refer to aldehyde. Or you can make a ketone where the CH3 here will be bring to that side and hydrogen will bring here. So it's going to be CH3, CCH3. So this is called as propanon, which is refers to a ketone. Okay, and the molecular formula is still maintained, which is C3H6, 1, 2, 3, H6O. Okay, the same goes to propanal. 1, 2, 3, C3, hydrogen got 6 and 1 O. Well, it is still maintained. Now let us look into example number 3, which is molecular of C3H6O2. So for the C3H6O2, we're going to have the carboxylic acid and ester. So we can draw a carboxylic acid which has a functional group of C double bond O, OH. Okay, and here going to be CH2 and CH3. Okay, or you can draw, okay, this is known as propanoic acid because it has 3 carbon change, which refer to a propanoic acid come from the carboxylic group. Or you can draw an ester where it has a C double bond O and O. And this is known as methyl ethanoic. Okay, so you will learn more about this in the chapter of ester. Okay, so basically the idea is that from the same molecular formula, you can produce 2 different functional groups. Now we do question number 1. So we have to determine the type of isomerism for C6H12. So C6H12 basically refer to alkene, which is CnH2n. Okay, so it refers to alkene. So if you were to draw an alkene, you can draw it as CH3, 1, 2, 1 carbon, 2 carbon, 3, 4, 5, and 6. So this is the skeletal structure. Okay, you can also draw the expanded structure if you find it helpful. Okay, but for me, I want to simplify it, so I'm using the skeletal structure. So we have 1, 2, 3, 4, 5, 6 carbon, and one of the carbon going to be a double bond. So for in the skeletal structure, the hydrogen is being high. Okay, as what you have learned in the first video of chapter 4. Okay, so we have to determine the type of isomerism. So for this case, this is the structure that I have drawn, and firstly, I put my double bond here, but I can also put my double bond to here. Okay, so there's no problem with that. So this is called as, okay, and I can also bring the double bond to here as well. So no problem. Where this is called as the positional isomerism because I change the position of the functional group. Okay, and same goes to here because I change it to here. So this is called as the positional isomerism, where 1, 2, and 3 are isomer between one another. Or I can make a functional group isomerism because I know that from alkene, it can convert to cycloalkane. So it has 6 carbon, right? So I'm gonna go and become and producing a 6 carbon cyclic compound. 1, 2, 3, 4, sorry, 1, 2, 3, 4, 5, 6. Okay, so this is the cyclic compound, and we're gonna make a hydrogen here, 2, 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 which refers to H and H, but I only put H2 to simplify. So in this case, my formula going to be C6 because 1, 2, 3, 4, 5, 6, and my hydrogen going to be 2, 4, 6, and 10, 12, H12. Okay, so it is still the same as in the question. And as what you can see, the type of isomerism that we can get is positional isomerism as well as functional group isomerism. Alright, so from one same question, we can get a lot of isomers. Alright, so this is the summary of what I have just taught. So basically, in this video, I focus on this part, which is the constitutional isomer. We have chain, positional and functional group. And we also do one question regarding the combination of all these three. In the next video, we're going to go into the stereoisomer, which focus on the cis-strand and optical isomers. All right. So I think that's all for today's video. See you again some other time. Bye.